Right then, so today I'm going to be looking at power calculations. So just before I get into the power triangle and exactly what power is, I'm just going to go through these few little bits here. So, power is the measure of the number of coulombs times the voltage. So how many coulombs are passing per the volts. So power is a unit of energy, so it's always measured in joules. That's its base unit, joules. So 1 joule, which is equivalent to our power, is 1 coulomb times 1 volt. Or if we put it into an equation, W, which we measure power in watts, so it's in W, equals Q, which is charge, times our voltage, which is V. So just to explain this into a bit more of actual sense. So let's say here we've got all of these copper atoms with our free electrons all at the top. So for ease's sake, we're going to say that each one of these copper atoms is 1 coulomb of free electrons. Obviously it's not, because it's over 6 trillion free electrons in real life, but just for this diagram it makes a bit more sense. So let's say then we've got an EMF applied to this, with one side attracting the free electrons and the other side repelling the free electrons, so in normal cases of a battery. So as this EMF is applied, these free electrons move from atom to atom, so they jump from there to there to there. So as this one moves, this one becomes imbalanced, and then it pushes it onto there, and then goes onto there to there. So this here, this green line, as the free electrons are moving, as we already know, this is our current. Okay, so the voltage, the EMF, just pushes the current along. So it's not actually travelling through the circuit, it's just at the beginning of the circuit providing that force to push the current along. So as the current is going along, so the act of that free electron actually moving from one atom to the next creates our electrical energy, so our electrical energy in joules, and we measure this in watts. So as it's physically moving from one electron to the next, it creates this electrical energy. Okay then, so then next we're just going to have a look at this power triangle. So this power triangle is the basis of all our power calculations, so if we've got a circuit. So we're just going to label it up. So P stands for power, I stands for current, as it always does, and V stands for voltage, as it always does. So we measure power in watts, current we measure in amps, voltage we measure in volts. So WAV. So just like the Ohm's law triangle, if we wanted to work out P, you put your hand over the P, and then the equation would be P equals I times V. So just to clarify that, this line here represents divide, this line here represents times. So if we want to work out power, it would be I times V. If we wanted to, using this triangle, if we wanted to work out current, just cover current up, it would be P divided by V. So next we're just going to have a look at our power calculation. So this is the first power calculation we're going to have a look at, and there's 3 in total. So I'll show you how we use all 3, and then I'll show you how we derive all 3 calculations, or at least 2, the last 2. So on this circuit here, we've got a current of 14 amps and a voltage of 25 amps. So if we want to work out the power, P equals I times V. P equals I is our 14 amps times V, which is our 25 volts, P equals, so we're just timesing those together, and that is giving us 350, and we are measuring it in watts. 350 watts of power is being consumed, being dissipated by that circuit. So that's the first calculation, and this one only really applies to DC circuits, so circuits with a direct current such as a battery or a solar panel or something like that.